Welcome to my YouTube channel. Today I am going to solve one cantilever beam SFBM, shear force diagram and bending moment diagram. So lot of video already before we did, but almost all video have same all problems have the same method. So if one problem you are understanding, I think so you can solve the any type of problem for the cantilever beam. So now these problems I am going to start now. So first what we'll do, we'll find the shear force calculation, then we'll draw the shear force diagram, then we'll go the bending moment calculation, we'll draw the bending moment calculation. For that rule is there, sign conventions we have to obey. So sign conventions for the shear force, what I will do, see here, I am taking, this is the section, this is the section, just 1 minute. So from the sections left side and right side, we'll assume. So suppose this is the section. This is right side, this is left side. Right side means this side right side, this is the left side. So what you have to remember, downward force will be positive. Downward force will be positive. Remember this only. Remaining what? Remaining what means, suppose you are coming here, upward force will be negative. You come the left side means upward force will be positive. Upward force positive, here downward force will be negative. So that complicated is there. So what you do, remember only one and other three, just you write it. Okay, that again I will show you. So this is only enough for drawing the shear force diagram. So before this we have to do the shear force diagram calculation. So see here, shear force diagram calculation. Neat and clean diagram you have to draw and the calculations work. So I'm taking the right side downward force all will be the positive. So first point will be, symbol will be S means shear force at point B. What is there, any force is there? 7 kilonewton. 7 kilonewton. Now shear force, this direction is downward direction is positive. So positive shear force over. Now what you have to do, see here, A, B the given. Now another point we have to write yourself. This is C, this point is nothing but D, this point nothing but E, this point nothing but F. So AB is the cantilever beam where various load is there, point load, UDL, and in between point load here UDL. So infinitely distributing load. So all the points are given. Now we'll see the SC. SC. In between no load. In between no load. SC means same thing will be there, 7 kilonewton up to C. Now D, SD. SD. SD, see here, how many load will be here? UDL and point load both will be there. So what we'll do here, SDR and SDL will find. What is meaning of SDR? Because you are taking right side. Just before this point is known as SR. And particular this point, suppose D I am taking now. So just before this D point is nothing but R, and L means we will consider this point load also. So SDR means first 7 kilonewton as it is will be there, plus, because 7 kilonewton up to point C. Now this much only need shear force. What is this one? Load we have to convert 4 into, because this 4 UDL is 4 kilonewton per meter, but distance up to 5 meter only. So we'll take 5 into 4. So 5 into 4. 5 into 4. So how much it will come? 27 kilonewton. How much coming? 27 kilonewton up to R. Now if we'll take the SD, okay, SDL. SDL means 27 up to just before this point. Now D na just 4 add. 4 add. How much will be there? 31 kilonewton. Because unit is the kilonewton, so it will be the kilonewton. Now we'll come to SE. SE. SE, only single force UDL is there. So up to at point D, how much? 31. Up to at D, 31. Then remaining this part only UDL. So UDL how much is there load? 4. And distance how much? 4. So plus 4 into 4. plus 4 into 4. So how much it will be there? 31 plus 16. 31 plus 16, it will come maybe 31, 16 plus 31, 47. So it is coming 47 kilonewton up to E. Now up to F. If we will find SF, in between no load, E and F between no load. So same things will be there, 47 kilonewton. Now last SA. SA. What is SA? Right here itself. SA. Up to point F is 47. Up to point 47. Now this is the UDL. What is 3 into 3 plus 3 into 3? Because all the forces downward direction is positive. So everything will be positive. 47 plus 9. 47 plus 9, it is coming 57. 57 or 56. 56. 47 plus 3, 57. 56. 47 plus is 56 kilonewton. 56 kilonewton. So calculation parts you have to carefully watch. 57 for 57 kilonewton. So this is the total shear force. If you want this is check correct or not. Total load how much? 9. 9 plus 4, 36. 36 plus 9, 36. So total if you will add this, all the forces you will add, it will come 56 only. That is called support reactions also. Okay. So now we will draw the shear force diagram. We will draw the shear force diagram. So each point, B point is 7 kilonewton positive. So you go the B point, 7 kilonewtons. Always you draw by the scale pencil. So 7 kilonewton. So here I am writing 7. Unit I am not writing due to space. 7. That means this will be 7 kilonewton. Now in between C, B and C, no load. So draw the horizontal line. Draw the horizontal line. So this also, what is the rule is there? If, see here, shear force diagram. Suppose point load diagram will be horizontal. UDL diagram will be inclined line. UVL, uniformly varying load, will be the second degree parabola. If same points, bending moment will be there. Bending moment diagram for point load, it will be, point load will be the inclined line for point load. Now UDL will be for bending moment diagram will be second degree parabola. This is second degree parabola. If UVL will be third degree parabola. This you have to also remember. So now here point load, no load na horizontal line. Now C to D, up to C same 7 to 7. Now up to D, what is up to D are 27 kilonewton. But this is UDL, so we will go the inclined line. Up to C. Now see here SDR, SDL. That means one more point load is acting. So how much this coming? 31. So here itself we have to draw the another vertical line. This will be 27. This will be the 31. Now E, SC 47. But here given UDL. So again inclined line. Again will be the inclined line. How much? 20 SC 47. So 47. Now in between EF, no load. That means this will be the horizontal line. In between no load. So it will be the horizontal line. Again A, SF will be 47. So 47. So here suppose two load will be there. Now see how 27, 31. This is SDR. This is SDL. L means just consider that point. Now again will be the inclined line because the given what is UDL is there. So it will be the inclined line. So this will be the 56. This point A, this point is F, this point is E, this point is D, both D, L, D, DR, This is the C. So all points once you know this H, this This is known as shear force diagram positive. So everywhere this lines you H means this inside area will be the shear force diagram. So shear force over. So see the concept, how much simple. Shear force means what is there? The algebraic sum of the all the vertical forces at any section of a beam to the left or right, we have to summation panna, algebraic sum add panna. So what we did? Add pan. I did the addition work 7, then remaining 27. So all continuously we added and we reached the 57. So now we'll go the bending moment diagram calculation. Bending moment diagram calculation. These also similar things. So you know moment is nothing but what is? Moment is nothing but force into perpendicular direction. Force into perpendicular distance. Moment is nothing but, suppose this is point A, this is the 6, this is 6, 5 or 6. If you take moment about A, what is? This is the rotation, clockwise rotation. 5 into 6 clockwise, this is the moment. That means rotations only, either clockwise or anti-clockwise. This is the moment here. So this is called bending moment here. We'll calculate. Okay. So see the bending moment at point B. So M is bending moment at point B. So at point B, na say 1 kilometer passing through the same point. So bending moment will be 0. Bending moment will be 0. If we take the MC, bending moment at point C. Before this, you should know the sign convention. You should know the sign convention. See, I will tell here sign convention. Only remember one part. This is the section, right side, left side. Clockwise is negative. Clockwise is negative. Remaining, this reverse, anti-clockwise is positive. This reverse, clockwise, anti-clockwise is negative. This anti-clockwise, this clockwise is positive. So this you remember, other things automatically reverse you have to do. Clockwise negative, this side anti-clockwise is positive. Either reverse, clockwise, anti-clockwise is negative, here positive. So top, this side is negative, this both are positive, but reverse of this. So remember this only to avoid the confusion. Now clockwise is, because we are taking right side. We are taking right side now. 7 at point C, 7 into 5, force into perpendicular distance. What is clockwise? Clockwise is negative. So negative 7 into 5. 7 into 5. So 35 minus 35 kilonewton meter, because 7 kilonewton, this is 5 meter. So kilonewton meter unit. Now will come the MD. MD. So now see this point is fixed. Moment means MD with this point is fixed. Now 7 into total distance, how much? 10. 7 into 10. Then this part UDL only. 4 into 5 load, then half distance 5 by 2. So first what will write? Because coming clockwise, so negative 7 into 10. You take the square bracket plus, because I am taking negative common. Now 4 into 5 load first. 4 into 5. 4 into 5, this is load. And UDL, what is rule? 5 distance, because maximum deflections will come middle, or center of gravity point will be the middle. So UDL rule is the load into half distance. Load into half distance. So this is the at D. So how much calculations will come? 70 plus, just the calculations is with me. 7 into 10, 4 plus 5, 5 by 2. It is coming minus 120 kilonewton. It is coming minus 120 kilonewton meter. So this calculations part you have to revise always. So MD. Now ME. ME. So ME. Again all is coming clockwise only. From right side clockwise. So everything will come negative only. So negative take common. Now 7 into total distance, how much at E? 7 into total distance. 10 plus 4, 14. 14. Plus E you are taking. So this load you take point load. Point load is nothing but 4 into 4. Point load this na. Point load is 4 into 4. Now UDL. First load na 9 plus 9 into 4. Plus 9 into 4 or write force into perpendicular distance 4 into 9. Both are same, but write like this, okay? So 4 generally like this, somewhere 4 I am writing like this, so take care, okay? 4, 4. So 4 into 9 load, then taking from the E, so UDL is connected, so just 9 by 2, 9 by 2 half distance. I taken now here 4 into 5 into 5 by 2, 4 into 5 into 5 by 2. Now total is the load is that is even 9 into 4, then 9 by 2. So if this you will calculate, how much will come? Negative ME is coming minus 276 kilonewton. Minus 276 kilonewtons. Okay. So this is the moment at E. Now moment at F. Moment of F. See, take the negative common because everything is in clockwise. F. This point is fixed. Moment at this point is fixed. With respect to this point, everything will rotate. 7 will rotate, UDL will rotate, and point load will rotate. 3 forces is there. So 7 into 17. 7 into 17 first point load. Then you take this point load means 4 into 7 plus 4 into 7. This is also point load. Now UDL. UDL first convert load. 9. 4 into 9. To take plus 4 into 9. What is this? Is load converted into UDL into point load. 7, 9 into 4. Now 9 by 2. 9 by 2. This is half distance. But why I kept here gap? This UDL is 3 meter away from the our considering moment F. Point F. So this UDL is where? From the 3 meter. So add here 3. 3. So over. Now close the bracket. This also here. Close the bracket because negative now taking. So this value will come minus. Already we calculated this value. MF will come minus 417 kilonewton. Minus 417 kilonewton. Okay, minus 417 kilonewton. So, okay. So now MF, now MA, final bending moment. So similar method again we'll go. What is A point is fixed, all forces will rotate. Now 1, 2, 3, 4 forces will rotate. First 7 into total distance. Take negative common because all are coming clockwise. So 7 into total distance how much? 10, 14, 15, 16, 20. So 20 meter either. Plus take this point load 4 into 4 into 10. 4 into 10 this point load. Now this take UDL. UDL again convert into load. 4 into 9 load. Then 9 by 2. But plus why? How much? This UDL is from a point 6 meter. So 6. This part you have to careful. Here UDL is connected. Here UDL is from ME. ME UDL is connected. Here UDL is after 3 meter. Here UDL is after 6 meter. Then plus one more UDL is there. 3 into 3 load and into 3 by 2 only because UDL is connected from the A. So this is the moment about A. This is the moment about A. 7 into 20, 4 into 10, 4 into 9, 6 plus 9 by 2, 3 into 3, 3 by 2. So this value is coming minus this value is coming how much? 571.5 kilonewton. 571.5 kilonewton meter. Kilonewton, all are kilonewton meter you have to write, no? So equal to kilonewton, you write here, kilonewton meter. This you write also kilonewton meter because force into perpendicular distance. Kilonewton meter. Load is kilonewton. Kilonewton. Suppose Newton the given na Newton meter. Here Newton. So this way we calculated the bending moment calculations. Now what we'll do? We'll draw the diagram, bending moment diagram. That will be the work. So always all junctions you extend this point or extend this line. So it will be, this line should be very light line or you can draw by pencil. So it will be looks good. So always you draw very light line. So our bending moment and shear force diagram only should look. All lines should be thin line or 2H pencil. So this pencil, it will come very sharp. So bending moment 0. This is 0 shear force line. This is the 0 shear force line AB. Now bending moment line, bending moment I will draw the diagram. 0 bending moment line. Okay, so this 0 bending moment line. From there we will draw the bending moment diagrams. Okay, so look here. At point B, what is there? 0. At point B, bending moment is 0. Now bending moment at C, minus 35. What is there? Point load only. Point load bending moment, inclined line. So draw the inclined line from this part. Draw the inclined line. According to the space you can draw. No need to measure this lengthwise. So according to the space you have to draw. MD. Now MD will be UDL. So we will be draw here curve line, second degree parabola. We will draw the curve line, second degree parabola. This will be the MD, how much? 120. So minus will not write. Already this is the negative side, below the line, negative side. MD, MC then. MC how much? 35. MC will be 35. This is 120. MD is 120. Now ME 276. This also UDL. So this also will be the curve line. This also should be the curve line. Line little down. This should be the curve line. This is straight line. This is straight line, inclined line, not straight line. Your space not there na. Okay, this is inclined line. This is second degree parabola. This is second degree parabola. Now E how much? 276. 276. All should be there. Kilonewton meter. I am not writing everywhere. Now F will be 417, minus 417. But this is no UDL. So this will be the inclined line only. This is the inclined line only. How much? 417. 417. Now next will be the UDL. 571. So this will be the curve line. This should be the curve line, second degree parabola. You have to draw, keep the protector. So curve line should be there. So second degree parabola. Okay, so this line should be curved. So 571 kilonewton. So this point is A, this point is F, this point is E, this point is D, this point is CB, and you hatch this line. This is the bending moment diagram negative. Bending moment diagram. So according to our sign convention, this is the bending moment diagram comes. So this way we can calculate the shear force and bending moment diagram. So bending moment diagram also what is? Algebraic sum of the all moment force acting on the particular point, either right side or left side. So we consider here from the right side we are considering. Left side also you will consider similar diagram will come. So is right side if you will calculate, left side you will calculate the shear force na, we have to find first support reaction. Support reactions if you will find it will come 56. Again 56, this negative, see it will reducing order, it will reach from here to here, reverse order you will reach. So diagram will come same. So that way either take the right side or left side, nothing, no problem at all. Okay. So okay students, watch this video, share this video to friend, and one thing you remember, all the problems will be similar method. So varieties of problems already we uploaded. Any one or two problems just you practice, you can solve any type of problems. Okay. Okay students, thank you.